with a Mac. Yeah. Okay, so welcome one and all to the November meeting of the San Diego Astronomy Association. I got a whole lot of stuff. And also, if our guest speaker is there, Ryan, if you'll just pipe up and let us know that you're there.
Yeah. Hi, everyone.
Excellent, excellent. Thank you. So he's our guest speaker for this evening. So this is I just want to pop this. I got this little GIF of the moon in a full rotation from the Lunar Reconnaissance Orbiter. I thought it was really kind of a cool little thing, so I just threw that in there. So Dave, if you can take me to my next slide, and we're going to just start with kind of governmental business. So we have annual elections for the governing posts in the organization, and the nominating committee has come back with this list of individuals, and normally there isn't a big fight for positions, because unpaid volunteer slots are not always so exciting. But if anyone wishes to run for any of these offices other than the people that are on this list, please speak now. Okay. So if you will then advance me, Dave, 2 slides. Okay. So first I want to mention, because I always do, we have a calendar of events, and you can find our webpage at SDAA.org, San Diego Astronomy Association. You type in SDAA, we're the first thing that pops up in Google. Our calendars list all of these things. Also want to remind you, we have a Facebook, Twitter, and Instagram account, so you can follow those on your social media if you would like to get access to various announcements and things like that. So we announce our meetings there also, so make it easier for people to find. And then I just want to remind us all that particularly if you're a person who's maybe new to astronomy and just getting started, we have a telescope loaner program. And Dave, if you would put the link in the chat, so on your Zoom window, if you just want to copy that link out of the Zoom window or chat and paste it into the address bar on your browser, whatever that is, take you directly there. Otherwise, you can kind of search through the menus on our webpage, sdaa.org. So we have a variety of telescopes that we loan out for a few months, so you can try out different telescopes and learn what you like and don't like, and before you have to buy a telescope. So that's particularly helpful if your telescope is not working, or if you simply don't have one, or you're kind of new to astronomy and you don't even know what you like. So please take advantage of that for any of our members. And also, if you want to become a member, go to our webpage, and there's a membership link there to join our organization. So please do so you can take advantage of these kinds of things. Also, we have a great newsletter. And David, if you put the link to our current newsletter in the chat, you can also copy that link, paste it directly into a browser. It'll take you to the current issue of our newsletter, which has a great article on broadening your spectrum in radio astronomy. So if you want to read a little bit about another kind of astronomy that does interesting and different kinds of things to more the conventional kinds that we use, which is visual astronomy, go take a look at our current issue of our newsletter, and there's other great information in there. So next chart, please. So we have a merchandise store also on our webpage. Dave, if you put the link in the chat for that also, again, same, copy the link out and just paste it in a browser window, take you right there. It's getting cold outside now to go out and look at objects in the sky. So if you'd like a nice warm San Diego astronomer t-shirt or hat, here's your opportunity to get that very thing. And into the next chart. So I've added a new chart to my normal presentation. We have a YouTube channel. So on our YouTube channel, we put all of our monthly meetings. So if you want to go back and see something that we said or showed before, you can go take a look at that. And in addition to that, put up that we are featuring for this month one of our outreach efforts, which was a virtual outreach effort from the Oak Oasis County Park. We live streamed an astronomy event. And so you can go take a watch at that. So if you're one of those kind of astronomers who maybe doesn't like being out in the cold quite so much, and but you want some of what it's like and learn some new interesting stuff, go take a look at our YouTube channel, all free. You don't have to sign up for anything like that, but you should subscribe and press the bell so it'll notify you when we post new videos, which we do fairly regularly. So next slide. Okay, and if you will start this video.
Early in its history, Mars had a far more hospitable climate than the one that we see, with a thick atmosphere and abundant flowing water. So how did it evolve from warm and wet to cold and dry? Since 2015, NASA's MAVEN mission has been investigating this question by studying the red planet's upper atmosphere. Now, it has mapped high-altitude global wind patterns at Mars for the first time. During the closest part of its orbit, MAVEN skims through the upper atmosphere, ingesting air molecules and determining their composition with an instrument called NGAMS. MAVEN can also rotate NGAMS back and forth to measure the air's velocity. These measurements provide a snapshot of wind speed and direction along a track of MAVEN's orbit. Because the orbit evolves over time, or precesses, the spacecraft's closest approach to Mars drifts across the planet, allowing it to take snapshots at different locations. Over the past 4 years, MAVEN's tracks have added up, crisscrossing Mars at many locations and at various seasons and times of day, wrapping the planet in a web of observations. The measurements reveal how the winds vary with location and evolve throughout the Martian year. Now, scientists have used MAVEN data to build a global map of wind currents roughly 200 kilometers above Mars, the first time that winds have been mapped globally and at such high altitude anywhere beyond Earth. Within the new map, scientists discovered an unexpected feature: imprints of rugged terrain far below. As an example, during 2 of its orbits, MAVEN saw winds above the Tharsis Plateau diverting away from elevated terrain, driven by giant shield volcanoes reaching twice the height of Mount Everest. Here's how the process works. Down at the Martian surface, winds are forced around and over obstacles when they encounter mountainous terrain. Disturbances in surface-level winds also disturb the air above, propagating up through the atmosphere as gravity waves. When they reach the upper atmosphere, the gravity waves block the high-altitude winds, causing them to alter course and allowing MAVEN to sense the presence of mountains and valleys on the surface while skimming the edge of space. High above Mars, MAVEN is studying the upper atmosphere and reaching out to feel the breeze. It has now made the first measurement of high-altitude global circulation patterns and discovered a surprising connection to features on the surface. These measurements also shed new light on ancient Mars with its thick atmosphere and its warm, wet climate. By revealing how the climate of Mars works today, MAVEN is helping scientists piece together the early chapters of its dramatic history.
So we've had presentations before about the rovers running along the surface of Mars and the InSight lander measuring the geology inside the planet. So I thought I'd throw in one for the weather here. And if you'll take me to the next slide, we have short video by Dr. Noah Petro, who's project scientist on the Lunar Reconnaissance
Mars had a far
Orbiter.
more hospitable climate than the one that we see today, with a thick atmosphere.
And he does a kind of answer questions about the moon.
What the heck is that?
Hi everyone, I'm Noah Petro, the project scientist of NASA's Lunar Reconnaissance Orbiter spacecraft, which has been at the moon for over a decade now, sending back a treasure trove of data, including some spectacular images.
Take a look at that.
Inevitably, whenever NASA publishes a photo or releases a video of ours showing the lunar landscape, we get emails, tweets, and online posts from viewers asking us to further explain some of the weird looking visuals that they're seeing. So today we're going to look at these strange and mysterious looking features on the moon to answer the question, what the heck is that? So let's launch into this.
The moon.
In our video, Apollo 13 Views of the Moon, many viewers wondered about this strange looking circle with dark lines. So what the heck is that? Well, for starters, this is not the remnants of an ancient lake. And apologies to the sci-fi crowd, it's not a secret moon base with runways for spacecraft. This is a geological feature known as Komarov Crater. It's 80 kilometers wide and it's on the far side of the moon on the edge of Mare Moscoviense. The floor is covered with a network of rills that make it look like sun-dried mud. And it's a great example of a floor fractured crater, or FFC. So what made Komarov look like that? The leading idea among scientists is that FFCs are like volcanoes that didn't quite reach the surface. An impactor hits the moon, forming the crater. And underneath the crater floor, the impact creates a zone of broken rock called a breccia lens. Magma from deeper inside the moon rises into the cracks of the breccia lens, but something stops it from getting all the way to the surface. So it spreads out under the crater floor, forming what's called a sill. The magma and hot gases in the sill push on the crater floor from below, causing it to bulge and fracture like the top of a cake in an oven. The cracks you see are known as graben.
Release the graben!
Using data from the Lunar Reconnaissance Orbiter, scientists have cataloged over 100 floor fractured craters, just like Komarov. They are fascinating works of nature from billions of years ago.
Billions.
An image from the Apollo 11 mission has gotten a lot of attention over the years. Here you see a pair of craters known as Messier and Messier A. They don't look like the more typical round craters that you see on the moon. LRO has taken even more high-definition shots of these two sites, showing us incredible detail. These oval shapes and areas of ejected rock do look like they could belong in Star Wars as the crash site of the Millennium Falcon. And actually, the way you might imagine it seemed like that happening, with an object slamming and then skipping across the surface.
Eva looks like somebody's trying to get into the meeting. I'm not sure if you saw that.
You see, at very low angles, an incoming asteroid can actually become decapitated, with the top part splitting off at the impact and either escaping back into space or skipping to form a second crater. Think of it like skipping a stone across the water. Both laboratory impact experiments and computer modeling have demonstrated the physical effects of the oblique impact of a large asteroid on the moon. And LRO's data helps prove the formation of these unusual features.
Hello.
Scattered across the lunar surface are these long, winding features, which many viewers have correctly assumed are channels. On the moon, these are called rills. There's a prominent one here on the Aristarchus Plateau, and if you're comparing to visuals on the Earth, you might be tempted to think about long river canyons flowing in long, sweeping meanders, like the mighty Mississippi pouring out into the Gulf of Mexico. And if that's what you're thinking, erase it from your memory, because it's wrong. Now, to be fair, when these channels were observed on the moon for the first time, there was an immediate thought that water may have carved these features. But once we got actual samples from the moon, combined with additional spacecraft data and studies over the years, we've come to understand that there was never flowing water on the moon. So what could carve these sweeping features? If you said flowing liquid hot magma after it erupted on the moon's surface, you'd be correct.
Winner.
When lava flows across the surface, it erodes the crust and slowly flows as it bends and turns, forming these beautiful channels. We have a great view of this in our Rima Prins visualization. Here you see a long channel where lava once flowed from the Vera volcanic depression. Eruptions of lava fountains formed a lake of lava 300 meters deep and carved a lava channel 100 times deeper than anything found on the Earth. These types of features were so compelling that the Apollo 15 mission went and explored one in 1971, known as the Hadley Rill. Future explorers may want to visit others, but they should leave their fishing rods at home. This visual is one of our most popular. This is a picture of Tycho Crater and the famous Central Peak boulder, which is about 400 feet wide. Now that's longer than a football field. Whee! How in the world did that wind up there? Well, I have no idea.
No, dadgummit.
We're going to fly now into a spot on the near side to look at this weird feature, which has long defied an easy explanation. It's known as Reiner Gamma. Those squiggles and swirls sure are bizarre. A combination of computer modeling and data gathered from numerous recent lunar missions, including Lunar Reconnaissance Orbiter, now sheds light on the origin of these unusual surface decorations, which we call lunar swirls. Now think of it this way. You've probably been told that when you go outside to put on your sunscreen. Well, these beautiful swirls are constant reminders that the moon is no different from you and me, except that it's a moon and we're humans. These swirls are examples of what happens when the moon applies SPF 3 million. The moon is constantly bombarded by radiation from the sun and galaxy, as well as micrometeorites that sandblast the surface. These swirls, however, show what happens when the radiation is blocked from reaching the surface. Data suggests that small magnetic anomalies block radiation from reaching the surface, and therefore prevent the moon from getting sunburned in these areas, which keep them as bright as they appear to be. So the next time you put on sunblock to go lounge outside, think of the moon and how it gets baked in the sun, just like you and me. Thanks for watching today. Hopefully this video taught you more about the moon and that you aren't left thinking, what the heck was that? I'm Noah Petro, signing off.
Okay, so that was a little humorous. And for the next one, I thought I'd include an update on what is Hubble working on. Yeah, so one more slide forward, please. There we go. So this is the current project, will be one of its largest projects that the Hubble Space Telescope is going to be doing for near the end of its mission here. Okay, so you're familiar with things like the Messier catalog or the Henry Draper catalog, where they're building up just basic data on astronomical objects, and so this project, the Ulysses project for the Hubble, is going to be doing that, but for ultraviolet bright stars, which are the information that we can't get normally from the surface of the Earth, blocked because it's blocked by the ozone layer. So I thought that was kind of a little interesting thing. And now from the Hubble, we're also going to go not far, also in Earth orbit. In the next slide, we have a little video from the Canadian Space Agency on a bunch of little interesting vignettes on the International Space Station. So if you will run the video.
The question is, if you get a cloth dripping wet without gravity and you wring it out, what's going to happen? What will happen to a wrung out cloth? So, and I had to use equipment that was here on board the space station. We may have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. And it's compacted. It's put down into this little tiny hockey puck so that it saves space. But when you open up a hockey puck and you pull out your washcloth, this is the one I'm going to use for the experiment today. And so when you open up your hockey puck and turn it into a washcloth, it was compressed in a great big vise somewhere. Okay, so here's my washcloth, like a magic trick. And now I'm going to get this soaking wet, and then we're going to see what will happen when we wring it out. Meredith and Kendra suggested that I dip this in a bag, but bags don't hold water in space, so instead I filled a water bag. This has drinking water in it. And I'm going to squirt a bunch of water into this washcloth. Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet. It's becoming a tube of water. The water's all over my hands. In fact, it wrings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of has it stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth. And then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jello on your hands or gel on your hand, and it'll just stay there. Wonderful moisturizer on my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations. Great idea.
These are grade school students that are interacting with people on the space station, recommending little science experiments, and they get to see the result in real time. So if you'll take us to the next video, which is just a more general question about the space station, also from the Canadian Space Agency.
Hi, Chris Hadfield here aboard the International Space Station. We keep busy on board the space station. Long days, lots of work, physical exercise. At the end of it, you're tired. But how do you sleep in space? In order to make it comfortable for the astronauts, originally they were going to put us all in one habitation module with sleep stations all around it. But the way a station was eventually built, we have sleep stations inside Node 2, which is in the forward part of the station, and inside the service module, which is in the aft. A total of 6 small bedrooms, sleep stations, or sleep pods. And inside each one is just a sleeping bag tied to the wall. You might think it's uncomfortable not having a mattress and a pillow, but without gravity, of course, you don't need anything to hold you up. You can just completely relax And you don't even need a pillow. In space, you don't even have to hold your head up. So you can relax every muscle in your body, and your arms float up in front of you. Your head tips forward. But before I go to sleep, I gotta put on my pajamas, because I have space jammies. I'll be right back. Great. I'm in my super comfy Russian full-length pajamas. Nice for when you have to get up in the middle of the night, and ready to go to bed. I'll show you where I sleep. This is my sleep station, my sleep pod. This is where I spend up to 8 hours every day here on board the space station. It's actually on the floor, but once you're inside, you just can't tell.
And like so many of us, I guess I had to point out right in front of his face in his bed is his computer. um, so now our last little vignette from the International Space Station, Dave, if you will advance us to that. And this one is a medical issue question.
Hi, I'm Ashley, and I'm in grade 9, and my question is, how does being in space for so long affect your body?
It affects us a lot of different ways. It affects your bones, your muscles. But one of the ways that we're learning recently is it affects your vision. We don't understand why, but it makes some people's vision worse. And we're studying it and trying to figure it out. So we have a lot of new equipment on board just to test and understand our vision. One of the things we have is a tonometer. This is actually like a pressure gauge that you touch to your eyeball. We put drops, it's weird to put drops in your eyes with no gravity. You sort of touch the little drop thing to your eyeball. It spreads over your eye. And then one of the other astronauts will just tap the center of my eyeball really carefully about 10 times. And this lovely little tonometer will figure out the pressure inside my eyeball. That's one way to measure our eyes. Another is to look into the back of them. And so we put those drops in your eyes that dilate your eye, and then I actually put this up against my eye and plug this into a computer, and then I can look into the back of my eyeball, and there are expert doctors on the ground who are looking at my eyeball while I'm doing it, and we could take photographs and videos of the optic nerve, or at least where it comes into my eyeball, and the veins and the stuff that's inside my eye. So we can do it that way. And then also, we actually do ultrasounds of our eyeballs. And that's in order to see how our eyeballs are changing, what's going on with the optic nerves. And so we have a full ultrasound machine on board, but we don't need gel. You just put a ball of water in your eye, and then you touch the ultrasound to your eyeball, or just to the water above your eyeball, and move it back and forth. And with that, we can see our whole optic nerve. We can see the lens and the cornea and everything in beautiful resolution. It's something we've just started doing, and we have experts on the ground who are helping us do it. But with all of these things, we're trying to figure out how the human body works and what controls vision and how it changes when you take away something as simple as gravity. We're learning more about eyeballs, but we're also learning more about how to stay in space permanently. So if you go to Mars, you won't show up there with bad vision.
And I'll add to that. There's NASA is running a fascinating medical experiment on one of their astronauts, astronaut Kelly, that went to the International Space Station, spent an extended period of time there. He was heavily medically tested before he went, as was his identical twin. And then when he returned, they took more tests, medical tests, to try to tease out what are the effects of prolonged spaceflight on the human body and how might they have to accommodate that kind of situation. So that'll be fascinating, particularly for these long trips to Mars. That's where they're really starting to focus on. So if you can take me to my next slide. So we have a number of quasi-professional amateur astronomers, and so I'd like to show you some of their pictures, which I arm twist out of them. So many of you may know that Mars was very close approach to the Earth very recently, and so we have a number of our members have been taking pictures of Mars. So here's actually a picture of Mars taken with a 9¼ inch telescope from Alan Ruckles. So that's not an extremely large telescope. It's substantial, but it's not certainly the kind of telescope that many amateurs in our organization would have. And so I thought I'd share this one, taken with a color camera and using the software shown there. Takes a series of frames, and he's evaluating each of them for atmospheric disturbances and throwing out the ones where the images are more blurred by turbulence in the upper atmosphere. So I think that's really impressive. As you can see in the lower left side, there's actually a polar cap visible on Mars, which is frozen carbon dioxide in a little frozen water kind of thing. So that's really cool. Next slide, another beautiful image by one of our regular contributors, Carl Weber. So of the Lobster Claw Nebula. So he's taking narrow spectral bands in hydrogen, ionized oxygen 3, and ionized sulfur 2. This is a very long exposure because these are very narrow bands, 32 hours of total exposure time on this image. So, which I think is just gorgeous. So, there's the technical interest, that kind of tour de force of all the collection with the hardware and the processing with the software and everything. But then on top of that, there's the aesthetic beauty that this is just gorgeous. There's just beautiful stuff in the sky. And so even, it's like you don't have to be technical in any way to look at a picture like this and go, wow, that's just spectacular. So in the next picture, all right, so this has the not as interesting name, IC 1848, very similar, all the same color. He has these very narrow spectral band filters. Sulfur and hydrogen are actually red colors and oxygen is green, but they map them over into red, green, and blue for making the pictures in a method very similar that's done for many Hubble Space Telescope pictures for public release, whereas they do somewhat different things for scientific applications. This one is an even longer exposure, 36 hours of time at the telescope, collecting images in these very narrow spectral bands. Again, fascinating from the technical perspective. The equipment is listed there on the right, the scope, the camera, what are the filters that he's using, the mount he uses to point and track the object across the sky, the software he processes it with. But in addition to all that, there's again the just beautiful aesthetics of the image itself. So if you'll then take me to the next one. So this one is a very well-known image. Many of you who have taken telescope out in this anytime in the summertime, this is the Eagle Nebula, and if you look, it's a very wide field of view telescope, so you can actually see the eagle. It's just to the left of center of the image is the eagle itself. Beautiful, not quite as long because the Eagle Nebula is, of course, a very bright object, only requiring 18 hours of exposure. But even in this short picture, you're talking multiple days of collecting time over multiple days with your camera, and a lot of processing time to tweak it and match up the aesthetics. So, and then my next slide is tonight's what I call digital door prize. So Dave, if you will put the link to this in the chat. So you can copy this link, which is also on the right of the slide there, and put it in your browser. This is a free, you don't have to register, you don't have to do anything, online simulator for docking the SpaceX spacecraft to the International Space Station. So this is, so you have like controls like you would use in a video game on the lower right and lower left for running the thrusters on the spacecraft to tip it one way or the other, or to accelerate towards the International Space Station and dock. And so it's a free little online game you can play on any computer. It's all in your web browser. You don't have to download anything. You just go to that website and enjoy yourself. So that's tonight's free gift just for showing up.